redox reaction is defined as the reaction involving interplay between oxidation and reduction. Oxidation number. What is oxidation number? Oxidation number is the electrical charge on an ion or group of atoms. When it's on an ion, it is of this form. When it is group of atoms, it is also known as what? Radicals. Such as this. Such as this. They are known as radicals. Now, example of compounds and the oxidation number of the elements. Sulfur has oxidation number of +4, +6 in this respect. How can that be demonstrated? Sulfur of this form has oxidation number of 4 because you have -2 for oxygen, you have minus of it equals to 0. So here S minus 4 gives you 0. S equals to +4. So the oxidation number of sulfur here is +4. Here, sulfur, oxygen is -2. 3 of it equals to 0. Then S minus 6 equals to 0. So S equals to +6. So the oxidation number of sulfur here is +6, while here it is +4. In these respective compounds, sulfur 4 oxide, sulfur 6 oxide, and triiodosulfate 4 oxide. This is sulfur 4 oxide, this is sulfur 6 oxide, and this is triiodosulfate 4 acid. So these are the respective. Here you can see sulfur. Sulfur here is +2. Sulfur +4. Sorry. So sulfur here is +6. Then here it is +4. This is a compound of and is regarded as an acid here. Here you have a gas. You have a gas, but it's +6 here, +4. Connection of oxidation numbers and IUPAC nomenclature. What is IUPAC nomenclature? The full meaning of IUPAC is International Union of Pure and Applied Chemistry. Nomenclature of these compounds: tetraosulfate 6 acid, H2SO4. Triiodosulfate 4 acid, H2SO3. Then ethane dioic acid. This is ethane dioic acid. Here you have the tetra came about as a result of 4 atoms of oxygen. This sulfate 6 is the oxidation number of sulfur here is +6, and what is responsible for the acid is the hydrogen, is the proton. In the case of this, triiodo, as a result of the fact that it has 3 atoms of oxygen, then sulfur here, the oxidation number of sulfur here is +4, and the acid is as a result of the hydrogen. In the case of this, these two, they are inorganic acid, while this is an organic acid. Here you can see the 2 carboxylic group, dioic meaning 2 of the carboxylic group. The ethane, which is 2 atoms of carbon, 1 2. So that is what is responsible for the name, which is ethane dioic acid. This here you call them the nomenclature, which is very extensive in organic chemistry. What is an oxidizing agent? An oxidizing agent is a substance which has set electrons. It has set electron to itself. Reducing agent. Reducing agent is a substance that donates electrons. Redox equation. The redox equation is the equation that involve a particular atom exhibiting oxidation and the other exhibiting reduction. To demonstrate the reaction and the change in oxidation number between two or more compounds in redox equation, it can be demonstrated by the reaction between acidified potassium tetraoxomanganate 7 and iron 2 tetrasulfate 6. This is potassium tetraoxomanganate 7 and this is iron 2 tetrasulfate 6. Here, when this species ionizes KMnO4, it gives you K plus MnO4 minus. Whereas here, iron 2 sulfate ionizes to give you Fe2 plus SO4 2 minus. The ion of interest here are this and this. So here you have MnO4 minus going to Mn2 plus, where the color of this is purple and the color of this is colorless. In the case of iron 2 plus, the color is green and the color of the iron 3 plus is brownish. Now, to demonstrate redox reaction for these two equations is this. Balance atomically. We want to balance atomically now. We are to balance this atomically. First and foremost, we write the ion here going to Mn2 plus. To balance atomically, it is evident that manganese 1 is here and manganese 1 is here. So manganese is balanced. Now we have 4 atoms of oxygen here. And when you have 4 atoms of oxygen on the left hand side of the equation and you have none on the right hand side of the equation, to balance the right hand side of the equation, we need to add equivalent number of what? Water. So when we are adding, since we have 4 of oxygen here, automatically we are going to have 4 moles of water where you have 4 oxygen. And when 4 moles of water is added, it is evident on the right hand side of the equation that we have 4 atoms of hydrogen, which must be balanced with a proton on the left hand side. So to balance the proton here, we had 8 proton. So taking a look at this reaction, 1 atom or 1 mole of manganese is equivalent to 1 mole of manganese. 4 moles of oxygen is equivalent to 4 moles of oxygen. Then 8 proton is equivalent to 8 moles also here. So this one is balanced atomically. Now in the case of iron 2 plus going to iron 3 plus, 1 atom of iron, 1 mole of iron. 1 mole of iron 2 one mole of ion 3, so it is balanced atomically. Now to balance electrically, when we want to balance electrically, that means we want to balance the number of electrons. What we have done in the case of in the first case is to balance the number of atoms. Here we have to balance the number of electrons. Mn 2 plus 4 waters. Now to balance electrically, we have -1 plus 8. -1 plus 8 gives +7. That's the charge on the left hand side. On the right hand side, you have +2 charge. +7 charge to +2 charge. That means to balance this reaction electrically, we need to add equivalent number of electrons. And since we all know that electron is carrying a negative charge, that means that to balance electrically here, we need to add 5 moles of electron to the left hand side of the equation. When we have 5 electron to the left hand side of the equation, you have overall charge of +2. So, and that is equivalent to the right hand side. So we had 5 electron here. So when we have 5 electron here, the equation here is balanced electrically. +2 +2. Now, in the case of ion 2 plus going to ion 3 plus, ion 2 plus going to ion 3 plus, you have a +2 charge, a +3 charge, and we all know that if we want to balance electrically, we have electrons. This one is carrying +2 charge, this one is carrying +3 charge. To equivalent the +2 charge, we need to add 1